Before you start Lesson 15, make sure you complete Test C in the Test Masters, as well as the mental math and problem-solving parts at the beginning. You should always do those as well. Lesson 15 has two parts. The first part is on equivalent fractions, and then the second part is on reducing fractions. Let's just talk about equivalent fractions right now. And a good way to understand equivalent fractions is using fraction circles. Let's just draw two fraction circles, and one of them will split into halves, the other one into quarters. And let's shade in half on the one on the left. On the one on the right, let's shade in half of it as well. So we would shade in 2 of the quarters. Now we've shaded in half of each one, so we shaded the same amount, right? But we can write those fractions differently. This one represents 1/2. This one represents 2/4. Those are equivalent. I mean, we can look at those things that we've shaded. If that was two pieces of, or 2 pies, you'd still take half the pie out either way, right? But the fractions, the numbers that we use look different, 1/2 and 2/4. But they are equal. We know that they're equal. We can look at that and tell that those are equal. Now think about something else that we were talking about in the previous lesson on part, whole. When we're talking about fractions, you can write any fraction, if it has a numerator and denominator the same number, that's equal to 1, right? So think about that 1/2. If we multiplied that by 2/2, that's the same thing as multiplying by 1, isn't it? If we multiply by 2/2, in essence, we're really multiplying by a 1. I can just make like a big number 1 there, because that's what 2/2 equals, doesn't it? It's just 1. So anytime we multiply any number by 1, it's still the same value. 1/2 times 2/2 would be 2/4, right? That's what we have above there. We could multiply 1/2 by any value of 1 as a fraction. We could do it by 18/18 if we wanted to. Any fraction, as long as the numerator and denominator are the same, that equals 1. Like this would equal 18/36. That's still the same thing as 1/2. And this doesn't just work for half, it works for any fraction. Like say we wanted to do 3/5. An equivalent fraction of 3/5, if we multiplied the top and the bottom of that by 3, multiplied, in other words, multiplying by 1, but we're using 3/3 to equal 1, this would be a 9, and this would be a 15. 9/15 is the same thing as 3/5. Or we can say 3/5 and 9/15 are equivalent fractions. Let's go ahead and do a practice problem. Form 3 equivalent fractions for 2/3 by multiplying by 2/2, 5/5, and 8/8. So remember, that's how we make equivalent fractions, is by multiplying by a fraction that's equal to 1. Anytime we multiply any number, it doesn't matter if it's a fraction or not, if we multiply it by 1, we don't change its value. We may change the way it looks, though, because 2/3 times 2/2 is equal to 4/6. That looks different, but we know it's the same because we know we multiplied it by 1. Let's do the other ones in our head, and let's just put equal signs here. If we multiply 2/3 by 5/5, we would have 2 times 5 is 10, over 3 times 5 is 15. And then if we multiplied by 8, we'd have 2 times 8 is 16, over 3 times 8 is 24. Those all equal each other. Now something else to consider here, and maybe this just seems strange to you because you're just not used to working with it yet, but you just have to understand that 2/2, anytime you have the numerator and the denominator are the same number, that fraction equals 1. So 2/2 equals 5/5 is equal to 8/8. All of those values, all of those fractions, they equal 1. Even though they look different, they all equal 1 because the numerator and denominator are the same number. And here's one you have to think a little bit more about. Find an equivalent fraction for 3/5 that has a denominator of 25. Okay, so we know that in order to make an equivalent fraction for 3/5, we have to multiply the top and the bottom by the same value. And to get 25 in the denominator, that means we need to multiply the denominator by 5, since 5 times 5 is 25. That means the numerator has to be a 5 as well. And we get 15 over 25th, or 15 over 25, 15 25ths. That is our equivalent fraction to 3/5. Let's do a couple of more. Look at practice problems C and D. We're talking about equivalent fractions there, otherwise we couldn't put an equal sign in between those two fractions. They have either a missing numerator or denominator, so you need to figure out what value would go there. So why don't you pause the CD and work on those two, and then you can turn the CD back on to check your answers. On problem C, you just have to think about what would you multiply 4 by to get a denominator of 32? Well, that would be 8, right? So that means you need to multiply the numerator by 8 as well. And so the unknown value would have to be 8 on that problem. Now over on D, in order to get 15 in the numerator on the right side, you'd have to multiply by 3. 5 times 3 is 15. That means to get an equivalent fraction, the denominator also has to be multiplied by 3. So it's 8 times 3 is 24. 5/8 equals 15 24ths. Let's do one more problem on equivalent fractions, and then we'll go on to the second part of the lesson. We have a word problem here, so let's read it through first. Find a fraction equivalent to 2/3 with a denominator of 12. Next, find a fraction equivalent to 1/6 with a denominator of 12. Subtract the second fraction from the first fraction. Now, on this word problem, there's not like one particular question we're trying to answer. There's just several steps in this problem. So let's just do what it says. Start with the first sentence. Find a fraction equivalent to 2/3 with a denominator of 12. Well, wouldn't we multiply by 4 over 4? We'd have 2 times 4 is 8 over 3 times 4 is 12. Next, find a fraction equivalent to 1/6 with a denominator of 12. So we'd multiply by 2 over 2, right? And we'd get 2 over 12. And then they want us to subtract the second fraction from the first fraction. So we can put a minus sign in there, and we'll get 6 over 12. Now 6 is half of 12, right? So really, this is like writing 1/2. We could reduce that to 1/2. We'll talk about reducing fractions next. One thing that I want you to see in this problem is that we did 8/12 minus 2/12, but think about what we started with. 2/3 minus 1/6. Now you look at that and you're like, well, I can't do that subtraction. I can only subtract fractions if the denominators are the same. But that's what we did there, is we made the denominators the same, right? We made both the denominators 12 by multiplying above and below by the same value, or in other words, multiplying each of those fractions by 1. We were able to make the denominators the same, and then we were able to do our subtraction. Just something to keep in mind for later lessons is you'll be multiplying by a fraction that's equal to 1 in order to get common denominators to do some subtraction problems when the denominators are not the same. Well, now let's go on to reducing fractions, and let's talk about that. And like we did a reducing of a fraction in that last practice problem, we had 6/12, and we reduced that to 1/2. We knew that that was an equivalent fraction. Now, the first part of this lesson on equivalent fractions, what we did to make equivalent fractions, like let's say just of 1/2, we multiply by the same numerator and denominator. like 2 over 2 would give us 2/4, and that's equal to 1/2. Now to reduce fractions, you basically do the opposite of what you've been doing to find equivalent fractions. For example, 6/12, what we did there was we divided above and below by the same value. 6 divided by 6 is 1. 12 divided by 6 is 2. And we could also, let's just do it over here, we could also divide above and below by 2. That would give us 3 over 6. But that's not the most reduced form of 6/12. When you reduce a fraction, you want to reduce it to what's called its lowest terms, the lowest value that you can possibly get for the numerator and denominator. And the way you do that, the way you get the fraction in its lowest terms, is you divide above and below by the greatest common factor, GCF. If you need to review greatest common factors, go back to lesson 6. That's where you learned about that. Let's go ahead and do a few problems. And what we have to remember on these is you divide above and below by the same value. That's how you reduce a fraction. And you divide above and below by the greatest common factor, the factor that both of them have in common, both the numerator and denominator have in common, but it's also the largest factor that they have in common. For example, all of these numerators and denominators will have 1 in common, right? That's the factor of any number. That's kind of pointless to divide by 1. Let's look at practice problem F. We could divide above and below by 2 because we know that that's a common factor since both of those numbers are divisible by 2. But that's not the greatest common factor. 4 would be the greatest common factor. So if we divide above and below by 4, we would have 4 divided by 4 equals 1. 8 divided by 4 is equal to 2. 1/2 is our answer there. And we want to ask ourselves, when we're finished reducing a fraction, is that reduced? Is there another greatest common factor we could divide by to change the way that number looks? And no, there isn't. 1/2 is as small as we can get. Now why don't you go ahead and do the rest of these, pause the CD and try to figure them out, and then go ahead and turn the CD back on and check your answers. You should be able to do most of these in your head instead of having to write down division symbols every single time. Go ahead and try to solve them in your head. On G, we have 6 over 10. So 2 is the greatest common factor between those two. 6 divided by 2 is 3. 10 divided by 2 is 5. 3/5 is the answer. On H, the greatest common factor would be a 3. 9 divided by 3 is 3. 12 divided by 3 is 4. And just ask yourself, can I reduce that anymore? Can I reduce 3 over 4? No, I can't. On I, all you worry about is the fraction part. You don't worry about the whole number part on mixed number problems. So you would just have 4, just rewrite the 4, and then look at the 3/6. The greatest common factor would be a 3, and so you would end up with 1/2, 4.5. And a lot of these, especially these fractions that are equivalent to a half, it's pretty easy to see right away that it's a half, and they're real easy to do. Now 11/33, write down the whole number, 7 and 11/33. We need to reduce the 11/33. We see that the greatest common factor would be an 11, so 11 divided by 11 is just 1. 33 divided by 11 is 3. 7 and 1/3. That's as much as we can reduce that. Make sure, just think to yourself, does that answer make sense? 11/33 and 1/3. And you can always multiply the top and the bottom by 11 to make sure you did it right and get back to 11/33. And then K, let's do that one. Write down the whole number, 10. That's not changing. 9/36, 10 and 9/36. Both of those have a 3 in common, but that's not the greatest common factor. 9 is the greatest common factor. So we divide the top by 9 and get 1, the bottom by 9 and get 4, 10 and 1/4. Now that's the most reduced form of the fraction part of that mixed number. To find an equivalent fraction, you multiply above and below by the same value. To reduce a fraction, you divide above and below by the same value, which needs to be the greatest common factor. Let's do a few more. Just do the operations that have been indicated here, and then reduce the answer to lowest terms if you need to. So the first one, you add those two fractions together, and you get 6/8. And we've done a few problems. I mean, we've talked about reducing fractions a little bit before we got to this lesson, but now we know how we get those fractions reduced. We divide above and below by the greatest common factor, which would be 2 in this case. 6 divided by 2 is 3. 8 divided by 2 is 4. 3/4 would be the reduced form of that fraction. And we say it's reduced to its lowest terms. Terms is just another word for numbers. M, do subtraction there, and you get 6/9. And you just have to ask yourself, is that the reduced form of that? Well, there's a common factor other than 1, right? They both have 3 in common. That would be the greatest common factor. And so 6 divided by 3 is 2. 9 divided by 3 is 3. 2/3 is the answer there. And let's do one more. This one's multiplication. Just multiply the numerators, multiply the denominators. 10/24. And just ask yourself, is that reduced? Well, they're both even numbers, and so you know for sure they're not reduced. They both have at least a 2 in common, and that would be it. That would be the greatest common factor. So you do 10 divided by 2 is 5. 24 divided by 2 is 12. 5/12 cannot be reduced any more than that. It's super important for you to understand how to reduce fractions to their lowest terms, so that you just need to be able to do it so well that you don't even have to think about why you're doing it the way you are, because there's other more important things that you'll need to be concentrating on in some future problems. So do the practice problems that are in the book on page 79 if you need some extra help, and there's also supplemental practice problems in the appendix for this particular lesson, so do those as well. The more you do, the better you're going to be at it, and the easier your math is going to be later. So if you're struggling at all on this, you need to get yourself some extra practice in. Let's just do a couple more problems. These deal with percents, and what we want to do is write those percent values that I have as reduced fractions. You're thinking, well, how can I write that? Well, you just have to remember that percentage is a fraction, right? 80% means 80/100. Now, just real quick, you can tell that those would both have a 10 in common, and we'd end up with 8/10. Just ask yourself, is that reduced all the way? No, because we have two even numbers. We know we still have some common factors. 2 is the only common factor we have left, and we would get 4/5. And that's what you do on a problem like that when they ask you to take a percentage and reduce it to a fraction in the most reduced form. 80% is the same thing as 4/5. 65%. Let's do that one. Just do 65/100. Now we see numbers that end in zeros and 5s, so we know that those both have a 5 in common. And let's just go ahead and work on that for right now. We don't have to always get the greatest common factor first off. We can at least start reducing it and keep asking ourselves that question, is this fraction in its most reduced form? 65 divided by 5, that's equal to 13. 100 divided by 5 is 20. And that would be the most reduced form. We can't reduce that anymore. There aren't any common factors left other than 1, which we don't concern ourselves with. And then problem S, 4 over 100. That's what 4% is equal to. Now those are two even numbers, so we know they have 2's in common. They would also have a 4 in common, right? Because 25 times 4 is 100. So we do 4 divided by 4 is 1. 100 divided by 4 is 25. 1/25 would be the answer. Remember that percent is just another way to write a fraction. That percent symbol is just shorthand for over 100. Do these practice problems that are in the textbook, besides just the ones that you just did if you need some extra help, and also do the supplemental ones in the back if you still need some more help as well. Make sure you understand how to reduce fractions.